Numerical analysis of reinforced concrete circular column strengthening with carbon fiber reinforced polymer under concentric and eccentric loading. The main objective of this study is to investigate the structural behavior of short circular reinforced concrete columns with different degrees of confinement achieved by carbon fiber reinforced polymers, subjected to concentric and eccentric loading. Figure 1 shows the details of column specimen, and Figure 2 illustrates the schemes of different carbon fiber reinforced polymer confinement. In this study, the numerical analysis by using improved concrete damage plasticity model was as implemented in ABAQUS software for finite element analysis was used. A total of 24 numerical specimens were modeled and simulated, and the results were obtained for them. Figure 3 shows the overall or general modeling using the ABAQUS software. In these figures, we can see in Figure 4 and Figure 5 the verification of the numerical model with those obtained from experimental data from the literature in terms of failure mode and damage shape as shown in Figure 4, and in terms of the load versus longitudinal displacement. Both results show as good agreement between the test result and the numerical. The result was expressed in different terms. One of them, for example, in Figure 6, the ratio between the axial compressive strength to the eccentricity of the applied load. And in Figure 7, we can see the overall load versus longitudinal displacement curves for all the tested specimens and columns, and we see they divided into 5 groups according to the eccentricities and ratios of confinement. Also, this figure, Figure 8, shows us the numerical damage or lateral plastic strains of the model. The verified numerical model was done in this study and give a good result and good agreement with experimental work, so that this numerical model can be adopted and it will be appropriate for this type of structural analysis. The result shows that as the load eccentricity increases, the axial strength decreases, and the reduction in strength will become more significant for unconfined specimen. Also, when the degree of confinement ratio increases, the strength increases and the reduction in strength will be limited. The increase in confinement ratio of carbon fibers will improve the overall column load-bearing capability. Finally, the ultimate longitudinal displacement and ultimate lateral strain both increase as the confinement ratio increases.